Alright, in this video we're going to continue to look at Chapter 12, and Chapter 12 focuses on shafts, primarily cylindrical shafts, whose, when you apply a torque to them, they twist. So if I have a line there from the center to the outside edge that starts off there, as we apply a torque to it, it's going to twist. So we have a torque T. It's going to twist some amount theta, which is going to be in radians, and that's going to cause a shear stress, which we represent with the Greek letter tau. So this is the stress, this is the twist, and this is the torque. So one thing that cylinders are used for in engineering is to transmit power or do work. So if we remember from physics class, if we just have a box lying on the ground and we push it some linear distance d, so we apply a force to it and cause it to travel a distance d, the work done is equal to force times distance. But if we're moving something in a circular path, if it's rotating and we're doing rotational work, that work is described as the torque T times theta. So it's our torque times the angle of twist, theta. That's going to tell us how much work is done. Now the amount of work done in a certain amount of time is equal to power. So power equals work over time. And in the English units of measurement, the unit for power is the horsepower. 1 horsepower is equal to 396,000 pound-inches per minute. So we're going to use the unit of inch here. We typically use feet, but in this case, because of the horsepower units, we're going to want to make sure our units of length are in inches. And the amount of time we're using is in minutes. So let's say that we did 396,000 pound-inches of work in 1 minute, and we wanted to convert that to horsepower. We would have to divide that by 396,000, and then the 396,000 here would cancel out here, and we would be left with 1 horsepower. So we're going to divide by this conversion factor right here to take our units of pound-inches per minute and get it into horsepower. So let's remember that horsepower is in fact a unit of power, which is work over time. And we've said that work is equal to torque times theta per time. And if these units are in pound-inches, and this unit is per minute, to convert it to horsepower, we're going to want to divide by 396,000. So this is equal to torque times theta over 396,000 t. I'll use a small t for time here. Now if I look at this theta over t, what this is telling me is how much twisting or rotating do I do in a certain amount of time. Typically, we don't use radians to describe how much something is turning. After all, this is frequently used in reference to engines or other machines that are spinning around many, many times. So rather than theta over t, the unit that we frequently use is rotations per minute, or RPMs. So we can replace theta over t with RPMs, like on a vinyl record player. So a little unit conversion here. We want this to be in radians. So if we want to represent revolutions per minute and convert that to radians, for every one revolution, starting and going all the way around to the beginning point, every one revolution is 2 pi radians. So if we do 1 RPM, that's 2 pi radians per minute. If we do 2 RPMs, that's 4 pi radians per minute. So in other words, we're going to take 2 pi times the number of revolutions, which we're going to represent as n sub r. Actually, this is the number of revolutions per minute, or RPMs. So 2 pi times n sub r is the basically 2 pi times our RPMs. But instead of using 3 letters RPM, we're going to use n with a subscript r. So this becomes, we want to keep it in radians, so we're going to say 2 pi n sub r times our torque divided by, the time is taken care of in the RPMs n sub r term here. So time is included here, so it doesn't need to be down here in the denominator anymore. And this is 396,000, just as a conversion factor. So, where am I going with all of this? Basically, it's just to derive the formula here for horsepower. Horsepower is equal to 2 pi n sub r t over 396,000. Okay, but we can simplify this because 2 and pi is a constant, and the 396,000 is a constant conversion factor. So this simplifies to torque times the number of RPM divided by 63,025. So we can calculate horsepower if we know the torque, the RPM, and then this is just a constant right here. Now, if we're using metric units, it's considerably simpler, as are most metric units. In metric units, the unit of power is not the horsepower, it is the watt. And 1 watt is equal to 1 Newton meter per second. So if we're using radian or revolutions per minute, RPMs, all we need to do with our metric units is take our 1 full rotation of 2 pi times the number of revolutions times our torque, and then divide it by 60 to convert our RPMs into our revolutions per second, which will give us the seconds we need to be in watts. So, to sum up, here is our formula for power in the metric system, and here is our formula for power in the English system.